Welcome to the course where we're going to learn JavaScript unit testing from the beginning, and no prior knowledge of testing is required. During the course we're going to be using one of the most popular testing tools for JavaScript applications called Vitest, which is based on another popular build tool, Vit. And that means that if your project is based on Vit, Vitest can reuse existing Vit configuration to run tests. And as for the application that we're going to test, it will be Vue.js application. But we're not going to test any Vue.js related parts. We will fully focus on testing native JavaScript code. So link to this repository will be in the video description. And now I'm gonna switch over to the terminal. I already have a terminal session opened inside root folder of the project. And the first thing that we have to do is to actually install npm dependencies. So let's run npm install. And after that, to run this application in the browser, we just have to run npm run dev. Let's switch over to the browser and take a look at the application. Just to give you an idea what this application is all about, even though we're not gonna be testing any UI related or Vue.js related code. But still, it is good to know what this application actually is. So here we can create different activities for ourselves. Then we can assign time for each activity that we'd like to spend doing that activity, and then start measuring time for each activity throughout the day by using these stopwatches. So as was already said, we're not going to test any Vue.js or UI related functionality. And if you're curious to see how this application has been built from scratch, I'm going to leave a link to the playlist in the video description, which shows how we were building this application from scratch. And also there will be a link to another playlist, where we have fully converted that application from JavaScript to use TypeScript. So before installing Vitest, let's talk a little bit about VS Code extensions that I'm going to use. To be able to see static errors and warnings related to quality of the code right from VS Code, I'm going to use ESLint extension. Next one, fileutils extension, allows to quickly create files and folders. Then I'm going to use prettier extension to automatically apply formatting to source files. Next one is pretty TypeScript errors extension, and this extension shows TypeScript formatted errors in a more readable way. Even though this course is about JavaScript testing, but we're actually going to use TypeScript, because everything that we're gonna learn regarding testing using TypeScript is also going to be applicable to JavaScript files. Next extension is called Tailwind CSS IntelliSense. That is because current project uses Tailwind CSS framework. The next extension is called Trailing Spacing, and what this extension does is it actually removes trailing spaces whenever we're gonna save files. And also, just because current application is built on Vue.js, I also have official Vue extension installed to provide support for Vue-related files inside VS Code. And also I have a couple more extensions that add Vue-related snippets. So now that we have finished talking about extensions, it's time to start installing Vitest. In here, let's open up the guide, and the command that we have to run to install Vitest is this one. And also please note, since we're going to be using latest version of Vitest, which is 1.5.0 at the time of this recording, we have to ensure that the current version of Vit in our project is higher or equal to 5, and Node.js version should be higher or equal to 18. So let's switch back to the terminal and run this command to install Vitest. And right after the installation process is finished, I'm going to open up package.json, and in here, to the list of these available scripts, I'm going to add one more script to run tests. I'm gonna call it test, and this script is going to run Vitest. So basically we will be able to run npm test or npm run test at the root of our project to run all tests. Let's try it out. I'm gonna run npm test. As we can see, Vitest has given us an error. That is because currently we don't have any tests in our project. And also please note that current project uses Vit as a build tool, and we already have configuration file vit.config.ts. And just because Vitest testing framework is based on Vit, it is going to reuse this configuration. So we don't have to add any additional configurations, which is pretty cool. I prefer running tests in a separate terminal application, but if you prefer, there is a VS Code extension called Vitest, which allows you to run tests right from within VS Code. So if you prefer doing it this way, feel free to install this extension. Now let's take a quick look at the folder structure of the project. Here inside Components folder we have a bunch of Vue components that we're not going to touch in this course. So instead we're going to focus on testing individual functions that do not depend on any Vue-related APIs. So the things we're going to learn in this course regarding testing will be applicable in any JavaScript application. So now that we have installed Vitest and done with all the initial preparation, we are ready to start writing our first test that we're going to do in the next lesson. Link to the source code of this lesson will be in the video description. Let's start with writing our first unit test. I'm gonna open up activities.ts. Some of the things in this file are related to Vue.js, so I'm going to skip those functions and focus on native JavaScript functions. And one of such functions in this file is called updateActivity. Let's write the test for this function, and according to some conventions, to store all test-related code, we can create a folder with the name test in the root of our application. And in here we're gonna place all test files that we're going to call the same as source files that we are testing. And just because the function we're about to test is located inside the file with the name activities, we're going to call this test the same. And also it is important to mention suffix test or spec. This way, when we're gonna run Vitest, it is going to search for tests in files with these suffixes. And that is why I'm calling this file activities.test.ts. And the first thing we're going to do in every test file is actually import function called it from the Vitest package, like so. This will be the main function that we're going to use to write testing scenarios. As the first parameter, this function accepts a string with the description of this testing scenario. So we have to come up with such description for this scenario that best describes what we're trying to test here. It's better to keep this description concise, not too long, but at the same time as readable as possible. And since in this case we're going to test the function which updates activity, I'm going to literally say it updates activity. And to be exact, it is not really a function but an object, which means we can call additional methods on it. And one of such methods is called toDo, that we can use to firstly describe all testing scenarios before actually getting to write test implementations. So when using this toDo syntax, if we're gonna run tests, Vit is not going to complain about absence of implementations for those tests. So I'm going to specify upfront all the scenarios that we're going to test. There will be only 2 scenarios. And in this case, those scenarios will correspond to individual functions. The second function we're going to test is called calculateActivityCompletion%. So let's get back to the test file, and I'm going to add description to the second testing scenario. It calculates activity completion %. So now after we're going to run npm test in the terminal, we're actually going to see those testing scenarios that we have written by using toDo method. So now we're going to write implementation for the first testing scenario. Let's remove this call to toDo method and pass a function as a second argument, like this. And before writing test implementation, let's talk a little bit about anatomy of the test. Usually each test can be split into 3 parts: a range phase, act phase, and assert phase. And sometimes those phases are also called as given, when, and then. In the arrange phase, we're about to prepare all necessary things needed to execute testing scenario. In the act phase, we're going to call the function we are about to test. And finally, in the assert phase, we're going to write our expectations that should be true in order for this test to be considered as passed. So now let's switch back to the file with implementation of the function we're about to test, update activity, and take a look at its implementation. As we can see, this function accepts two parameters. First one is an activity object. It has type of activity. So the activity object is basically an object with three fields: ID, name, and seconds to complete. And as a second argument, this function accepts another object, which is supposed to have some of those fields that activity object has, but with updated values that we're about to assign to the fields of an activity object. And this is exactly what this assign method call is doing. It basically takes fields of the second parameter and assigns them to the fields of the first parameter activity. And also it modifies an activity object referenced by the first parameter activity. So the first thing we're going to do is to actually call this function updateActivity in the second phase of our test. Let's call updateActivity. Right away we can see that this function is highlighted. There is TypeScript complaining about that this function accepts two arguments that we haven't yet passed. So we're gonna have to pass activity object that we're about to update, as well as object with updated fields to be assigned to the activity object. Just to remind you that an object of an activity type should have three fields with names ID, name, and seconds to complete. And that means that we have to prepare our data in the first phase of the test. So I'm going to create a constant activity that is going to hold a reference to the activity object. And here I'm going to describe an object of that shape with three properties: ID, name, and seconds to complete. And also to make it clear for TypeScript that this object is actually of an activity type, we can explicitly specify the type of this constant. It will be activity. We also have to import this type up above. And then I'm going to create another activity object, which is basically going to store new values for the activity fields. It will have the same shape as an activity object. The only difference will be in values of every field. So what is actually supposed to happen after we're gonna call updateActivity is this first activity object should have all its fields updated with values located in the fields of the second activity object. Because inside updateActivity function we're calling this method assign to assign fields of the second object into the first object. And finally we're going to write our expectations, what we're expecting to happen after we have called updateActivity function. So to write an expectation, we use function called expect. This function is provided by Vitest. Let's import this from the Vitest package. And then as the first argument to this function, we're passing the value we're about to check. In this case, we're checking activity object if it was updated. And then this call to function expect is going to return an object with a bunch of methods that we can use to do different checks. For example, in this case, the method we're going to use is called toEqual, because we're about to check that the activity object is actually equal to some another value. And this another value will be an updated activity object, because this object we have used to update fields of the first activity object. And this way we're checking that our updateActivity function has done its job. And indeed, in the terminal we're seeing that the first test has passed. By the way, when we ran npm test, Vitest has started in the watch mode. That means anytime we're going to change any of our source files, it is going to rerun tests. So it basically works similar to hot module replacement in the browser. Whenever we're making changes to source files and see changes in the browser without refreshing the page. And also while npm test command is running, we can use different keys to control test runner. For example, to rerun the test, we can press R, and to see all available commands, we can press H. Here we have a short description of every command and the key responsible for running that command. For example, to run all tests, we can use key A. Next, even though our test has passed, it's always a good idea to check if the test is going to fail when we're gonna comment out this function call to make sure that we're testing the right thing. And there we go, now the test is failing because activity object hasn't been updated. And we have some mismatches in the values of fields. Now let's also try to comment out an implementation of the updateActivity function and make sure that our test still fails. And it does. So at this point we can be sure that we are testing the right thing. But also please note that this function, besides updating the activity object, also has a return value. But even if we're not going to return anything from this function and take a look at our test, we can see that it still passes. So as of now we're not testing everything related to this function. Let's try to improve this test. That is going to ensure that we also return proper value from the updateActivity function call. I'm going to rename this constant updateActivity to be called updateDFields. And then let's accept returned value of the updateActivity function and store it inside of the constant updateActivity. So now we have a way to check what is actually stored inside this constant. And we also have to rename this variable on updateDFields just because we have previously renamed this constant. So now let's add another expectation and see if the value stored inside of updateActivity constant matches updateActivity. So we'll use the same method to equal and compare updateActivity with updateDFields. And as we can see, those two expectations are passed. But now if we're going to forget to return value from the updateActivity function, the test is going to tell us about it. As we can see, it fails now, because that function did not return anything. Let's also check that test is going to tell us that we have done something wrong, if for example we're going to return an activity object without updating it, like so. And indeed, test is failing now. So now we can be sure that the updateActivity function works as expected, because we have a test, and if we're going to break this function, test is going to notify us about it. And as a common practice, it is good to split 3 phases of a test by using new lines. The first phase is a preparation where we are preparing all necessary data to run our test. Then we put a new line, followed by the second part of the test, where we're calling that function that we are testing. And then comes another empty line, which separates second part of the test and the third one. And here we have all our assertions or expectations that should all be true in order for this test to pass. And this way we have written our first test. Let's continue in the next lesson. Link to the source code of this lesson will be in the video description. Let's continue writing unit tests for functions, and in this lesson we're gonna focus on writing the second test. So before writing an implementation, let's remove this to-do call, and instead let's pass function as a second argument to this it call, and in here we're going to describe the scenario for the second test. So before writing the implementation, let's just take a quick look at what the function we're going to test is doing. It's called calculateActivityCompletion%. As we can see, it takes 2 parameters, first of which is an activity object, and the second one is amount of seconds, which is a number. So basically this function calculates percentage of the amount of seconds passed as the second argument into this function. As a reminder, activity object consists of 3 fields. Those are ID, name, and seconds to complete. So now let's get back to the test and prepare data that we need in order to write test. I'm going to copy over the object from the first test, since we're gonna need it in the second one as well, because we're gonna have to pass the activity object as the first parameter into calculateActivityCompletion% call that we are testing here. As we can see, TypeScript shows us that this function should accept 2 arguments. So let's start passing those. First one will be activity object, and as a second argument we're gonna have to pass amount of seconds that we are going to calculate percentage of. So if the total amount of seconds assigned to this particular activity is equal to 3600, which corresponds to 1 hour, then if we're going to supply half of this amount, that means the percentage constant is going to store 50%, because 50% is the percentage of 1800 seconds calculated out of 3600 seconds. But firstly, let's just calculate what we're gonna get if we're going to pass 0 in here. Let's write the check in the third part of this test. We'll use function accept and pass result of calculateActivityCompletion% function, and then we're going to compare the result by using another method called toBe. This method is usually used to compare values of primitive types, strings, numbers, or booleans. So in here we have to check that percentage stores 0. We're doing it like so. So after this we can see that all tests have passed successfully. But usually it is a good idea to change implementation of the function in order to see the test failing, to make sure that we are testing the right thing. So in here I'm going to remove this part from the function implementation, and we are supposed to see the test failing now. But even after we have removed that part, we're still seeing that the test is passing, which tells us that our test for now is not covering all use cases. So what I'm going to do in here is call calculateActivityCompletion% function several times, passing different set of arguments to make sure that function works properly with all those arguments. Let's call the result of the first function called %a, the second one will call %b, and in this case instead of passing 0, let's pass 1800 seconds, which is twice less than total amount of seconds assigned to the activity in seconds to complete field. And if it is half, therefore %b is supposed to store value of 50. So we are verifying it in the same way by calling function expect and then calling toBe and comparing value inside %b with 50, like so. And this time test has revealed an error, so we know that for now our function is behaving in a wrong way. So let's get back to activities.ts and discard that change that we have previously made to make the test fail. After this, all tests are passing. I actually prefer adding one more function call to this list to test another scenario when we're gonna pass 3600 seconds. So in this case, we are supposed to get 100 in %c constant, because 3600 seconds is exactly amount of seconds assigned to seconds to complete field of this activity. So let's just duplicate this expectation, and instead of comparing with 50, we're gonna compare with 100. And there we go. So far, all our tests are passing, which means calculateActivityCompletion% function behaves as we expect. So now that we have finished writing the second test, let's take an overall look at the implementation of this test. And here we also can see 3 clearly defined parts. The part where we are preparing the data needed for testing. The second part is where we're calling the function under the test. And the third part is where we are describing all our expectations. But sometimes it might be useful to combine some of these parts into one. For example, in this test, I prefer combining the second part and the third one. So instead of calling all those functions separately and assigning return values to constants, I prefer calling these functions in line right inside expect function. This way we're making this test more compact, and I think readability is not going to be worse after doing this change. So I prefer to keep it like this. it's always a good idea to check if all tests are still passing after doing any kind of refactoring. And they do. And by now we already have 2 testing scenarios, each of which tests individual function. And this is actually the reason why these kind of tests are called unit tests, because they are testing individual functions in isolation. So by having these 2 tests, we can be sure that anytime we're going to refactor any of these functions that we are testing, if we're going to make a mistake by changing something that is going to cause these tests to fail, we will be notified right away thanks to our tests. Link to the source code of this lesson will be in the video description. Let's start working on tests for functions that are defined inside functions.ts file. So I'm going to create new file with tests with the name functions.test.ts inside test folder. And right here, as always, we have to import function it from the Vitest package to define tests. And first of all, before writing implementation for tests, I prefer to describe all testing scenarios. So we're going to start with testing the function formatSecondsWithSign, which is why I'm going to describe this scenario as it formats seconds with sign, which corresponds to the function we're about to test. The next scenario will be for the function with the name formatSeconds. Gonna mention this scenario right here. Moving on, and the next function we're going to test is called normalizeSelectValue. I'm going to add this scenario right here. The next function is called getProgressColorClass. Let's also create this scenario for this function. And finally, the last function we're going to test in this file will be a function called id. This function is used to generate random strings. So now that we have created all the scenarios we're going to test in the file functions.ts, we can start writing implementation for the first testing scenario. But the thing is that the function which we're going to test in the first scenario depends on another function. As we can see, it's calling the function formatSeconds. So it would make sense if we're going to start describing testing scenario for the second test. To test function formatSeconds. So let's see what this function is actually doing. It accepts one argument, which is amount of seconds, and at the end, it is going to give us formatted string. So for example, if we would call this function formatSeconds with the argument 60, we're going to receive such formatted string. If we're going to call the function formatSeconds with the value 10, we're going to receive the following string. And lastly, if for example we're gonna call this function with amount of seconds 3600, we're going to get such result, since 3600 seconds correspond to 1 hour. And now let's start writing all these expectations. I'm gonna get back to the testing file, and in here, let's call function formatSeconds. For this case, we're going to test what happens if this function would receive 0. In this case, we're gonna get formatted string where all digits will be zeros, like this one. So our first expectation would be as follows. We will use function expect, passing the result of the function formatSeconds, and at the end we expect that the return value will be equal to the following string. And now let's check the result in the terminal. Before I have to remove this code to to-do method, and we're getting this error related to generatePeriodSelectOptions function. The problem here is a little bit tricky, and what is going on is this. Here in this test file, we are importing function formatSeconds from the functions module, and inside the functions module, we have the import of several constants from another module called constants. But if we'll take a look at the constants.ts module, in here we're gonna see that the first import that we are using imports the function from the functions module. So we end up in the situation where two modules import things from each other. And that is why we're getting that error when running tests. So to fix that error, I'm gonna move a couple of functions from the functions.ts into constants module in order to make constants module not dependent on the functions module. So I'm gonna move generatePeriodSelectOptions as well as another function that is used inside this function called generatePeriodSelectOptionLabels. And I'm gonna paste both of these functions at the end of the constants module. So now we don't need to export generatePeriodSelectOptions anymore. Let's remove this keyword. And all we have to do in here is to import type called selectOption. And now we can scroll to the top and remove the import of generatePeriodSelectOptions function, since we have moved it inside this module. And also before checking test results, let's just go inside functions.ts and remove a couple of unused imports from here. And this way that error is fixed and our test is passing. So getting back to our test, and here I'm gonna call the function formatSeconds several times in order to see what results we're going to get depending on different parameters we're gonna pass into this function. And in this case, I prefer to combine these two parts of the test into one by calling the function formatSeconds in line inside expect function call like so. Let's check once again that the test is passing before proceeding any further. And now I'm gonna duplicate this line several times and change all these expected values. In the second case, we're going to expect 1 minute. In the third one, 3 minutes. In the fourth one, 30 minutes. In the fifth one, 1 hour. And finally, in the last case, we're going to expect string, which contains all zeros. So now we need to pass proper value into formatSeconds function in the second case in order to get such string, which corresponds to 1 minute. So to get this string, we have to pass 60 seconds. Let's comment out all other use cases for now and check if tests are passing. And they do. We can move on to other cases. In the third case, to get 3 minutes, we have to pass 180 seconds. In the fourth case, to get 30 minutes, we have to pass 1800 seconds. Like this. Let's make sure that all tests are still passing. And we are left with only 2 additional cases. In the fifth case, we have to supply 3600 seconds in order to get the string which corresponds to 1 hour. And finally, last case is kind of a special one. In here, I'm going to pass a number which corresponds to amount of seconds in 1 day. And to make it more readable, I'm going to multiply amount of seconds in 1 minute by amount of minutes in 1 hour by amount of hours in 1 day, and this way we're gonna get amount of seconds in a day. And due to specifics how formatSeconds function is implemented, if we're going to pass amount of seconds in 1 day to this function, at the end we're going to get formatted string with all zeros. And there we go, the test is green. So now I'm gonna switch back to implementation of formatSeconds function and change this implementation to make the test fail. This way we can be sure that we are testing the proper behavior. It is failing, just as we expect. Let's revert this change. And lastly, before finishing this lesson, let's switch to constants.ts and use keyword type when importing select option type. It's just a personal preference. I prefer to use type keywords anytime I import types. And with that, that's it for this lesson. Let's continue writing other tests in the next one. Link to the source code of this lesson will be in the video description. After creating the test for the formatSeconds function, it's time to create the test for the function that uses formatSeconds function. It's formatSecondsWithSign function. As we can see, besides calling formatSeconds function, it also has this ternary expression to determine which sign should be used. So let's start with copying all the logic from the previous test, paste it into the first one, and in here we just have to change a few things. Of course, we are testing different function with the name formatSecondsWithSign, so let's rename all these occurrences. And of course, after checking the test results in the terminal, we can see that we have a mismatch. because our new function is adding sign in front of the formatted string. So let's use proper expected values in here. I'm going to add plus sign in front of every string. And there we go. After doing this change, test is passing. And now let's switch back to implementation of this function and remove the ternary expression to check if the test is going to fail now. And it is. Now let's revert this change and remove this second part of this ternary expression. I'm gonna remove the minus and check what happens with the test. And as we can see, it is passing because right now we are only checking the first part of the ternary expression, which adds plus sign. But what about the minus sign? It is important to check all possible paths that function execution can go through. So we're going to do the same set of assertions in here, but in this case we're going to check if the minus sign has been added to the formatted string. And the minus sign is going to be added only if we're going to pass negative value of seconds into each of these function calls. So I'm going to use negative values everywhere and expect that formatted string will contain minus in front of it. So now we only have a problem with the first call of this function when we were passing 0 with negative sign. In this case, formatted string will still contain plus sign. As you can see, this ternary expression checks if passed value of seconds is greater or equal to 0, it is going to use plus. And that is why we have to use plus sign in front of this string. In this way, all expectations are passed. But here is the thing. After testing the function formatSecondsWithSign, we also implicitly tested formatSeconds function, which is called inside formatSecondsWithSign. So technically, we could just remove the test for formatSeconds function. But having tests for each individual functions has its benefits, because let's see what is going to happen if we're going to break this function in some way, check the test results. In this case, we're getting an error related to the first call of formatSecondsWithSign function. But we didn't change this function, we only have changed the function which is used inside of this formatSecondsWithSign function. So to get more precise feedback regarding of which function is actually broken, it's better to have tests for each individual function. Since we do the second test, which tests formatSeconds function, also fails. But if we would go ahead and remove this test, the only thing we would know after looking at failing test is that something has actually went wrong during formatSecondsWithSign function execution. So to be able to identify the root cause of the problem, we would have to spend a little more time. And that is why I'm going to keep both of these tests, even that having these two tests means that we're going to test formatSeconds function twice. Link to the source code of this lesson will be as always in the video description. Time to move on to the next testing scenario where we're going to test function with the name normalizeSelectValue. As we can see, it accepts value, transforms it in some way, and as a result, we are expecting to see the value of 3 different types, whether it will be number, string, or null value. So here we actually have a couple of conditions to check. We're going to pass values of different type into this function and expect that we're going to get proper types of converted values in return. And now let's just one by one call the function normalizeSelectValue with different types of arguments and check function implementation to see which type of value we're going to get in return. For example, what is going to happen if we will call this function with the string argument. In this case, the first part of this logical expression will be false, the second one will be true. So that means if we have passed string value at the end, we're going to get the same string value. Let's make sure that this is really the case. I'm going to print out value in the console. Let's add modifier only in order to execute only this test and check what we are going to get in the terminal. As we can see, test has passed, but we haven't even done any assertions yet. What's most important is that we are seeing the expected return value. So now let's write the first expectation by using function expect. and check that the returned value of this function will be equal to the string random string, like so. The test is still green, so let's check another scenario when we're going to pass null. In this case, the first part of this expression will be true, which means we're gonna get null in return. Because if we have initially passed null into the first parameter of this function, which is value, and we are returning this parameter right here, we're going to get null. So by checking that null equals to null, we're supposed to get test passing, and we are seeing that the test is still green. But the more interesting use case will be when we're going to pass number as a string, like so. In this case, the second part of this OR expression will be false, as well as the first one. So the second part of this whole ternary expression will be executed, where we are converting parameter to the number by using the plus sign, which means that we are expecting a number, but for now I'm going to compare that we are getting 1 as a string to make sure that the test is going to fail in this case. So the real value that we are expecting in this case will be 1 as a number. And this is it. This way we have checked all possible scenarios of this function. It's possible for this function to return values of 3 different types, and that is why we have used 3 different use cases to make sure that each case is covered. Of course, it's always a good idea to intentionally break the implementation of the function to see that the test is going to let us know that we have made a mistake in our function. So, test is failing as expected. Let's revert that change. And at the end of this lesson, I'm going to say a couple of words about a couple modifiers that we can use with it function, such as only and skip. So whenever we're using modifier only on some tests, that means that Vitest is going to run only these tests, ignoring all others. As we can see now, since we have used only modifier on 2 tests, we're seeing that only 2 tests are executed. Whereas if we're going to use modifier called skip on some test, that means Vitest is going to ignore that test and execute all others. So we have used modifier skip on the third test, which was ignored, and only the first 2 tests were executed. This is it for this lesson. Let's continue working on the next testing scenarios in the next one. Link to the source code of this lesson will be in the video description. Let's write another unit for the next scenario for the function getProgressColorClass. Let's take a look at the implementation of this function. As we can see, it takes one parameter, which is a number, and then based on the past percentage amount, this function is going to return proper CSS class, which is represented by ProgressColorClass enumeration. It contains list of Tailwind CSS classes, and also this function references a couple of constants that are defined inside constants.ts module. Alright, now that we know what this function is doing, time to write the testing scenarios. First of all, I'm going to call this function passing 0. In this case, the first conditional block will be executed, and we're going to get class which corresponds to the red element of this enumeration. So let's just compare return value with this element. We also have to import ProgressColorClass enumeration into this file, and then I'm gonna use function expect to compare these values, like so. So to be able to run only this one test, we can use modifier called only on the it object like this, and this way only this test will be executed. As we can see, our test is passing. But if we're going to comment out first conditional statement inside this function, the test will fail. So now that we have several if statements inside this function, it's also good to check all possible paths that our function can go through. So I'm going to duplicate this expectation several times and check all possible paths. For the second call, let's pass amount of percentage that is less than percentage stored inside the low percent constant. Under these circumstances, we're still about to get inside of the first if statement and get red element. So we are also comparing resultant value with the same one what we have used in the first expectation. Next one, I'm going to comment out the cert scenario, where I'm going to pass amount of percentage that is less than percentage stored inside medium % constant. In such case, we are about to get inside the second if statement. And the function is going to return element which corresponds to the yellow color of the enumeration. So let's use yellow in here. For the first scenario, I'm going to pass amount of percentage that is less than amount of percentage stored inside 100% constant, just to force the function go inside the cert if statement. In such case, as we can see, we are about to get color which corresponds to the blue element. So following the same principle, we are using different elements inside toBe method call to compare return values of the getProgressColorClass function with expected results. And finally, last case, if we're going to pass 100%, we are about to get green class. So right here I'm going to use green. All cases are passing, but as always, it's good to break implementation just to see if tests are going to fail, and they do. So we have successfully implemented the test for another function. Let's not forget that we have used modifier only. Let's get rid of it to run all tests in the project. All of them are passing. So by now we have almost implemented all tests in this file. There is only one remaining scenario, which we are going to take care of in the next lesson. The link to the source code of this lesson will be in the video description. Now it's time to write the last test implementation in this file, which tests function called ID. This is a pretty simple function, as we can see. But the technique we're going to use in order to test this function will be drastically different compared to previous functions. Because if we'll take a closer look at the implementation of this function, we can see that this function uses a couple of default objects provided by JavaScript. And what's even more tricky is that those functions, such as now on the date object or random on the mass object, they will always return different results anytime we're gonna call them, because method now on the date object depends on the current date, and method random on the mass object will return new random value anytime we're gonna call it. So in order to test this function, we should somehow force these methods return expected results. Otherwise, we're not going to be able to test this function. So the main goal of this ID function is to generate random string identifiers. I'm going to switch over to the test file, and let's try to call this function once and see what this function is going to return. I'm going to print out the result in a console. So right here we can see the generated string, and if we're gonna rerun the test, we're going to see a different string, because anytime we're gonna call function ID, we'll receive different identifier. So to make this function predictable, we should somehow make method now as well as method random return some predefined value which will not be dependent on the current time. Fortunately, Vite provides us with a way to do so pretty easily. First of all, we're gonna have to import object called vi from the Vitest library, and then we're gonna call method spyOn, which accepts two arguments. First one is an object where we're going to mock the method on, and the second argument is the method name itself that we have to mock, or that we need to spy on. In this case, we need to mock the return value of the function now, so that anytime we're gonna call it, we're going to get expected result. And we can mock the return value of the function by calling method mockReturnValue once and providing the result that we want this function to return. In this case, it doesn't really matter which result it is going to return, so I'm going to use 1. Before going any further, let's firstly comment out this line and make sure that method now is going to return different value anytime we're going to rerun tests. So we see that return value changes every time I refresh test execution. But if we're gonna use spyOn method call and check the result again, this time regardless of how many times we will refresh test execution, we will always get predefined value 1, which we have specified when calling mockReturnValue1's function. So now we're gonna do the same for the other function, which our function ID depends on. It is a random function on the mass object. In this case, I'm going to make this function to return 10,000. As always, before continuing with implementation, let's just make sure that random method call is going to return 10,000. So now that we have mocked return values of both of these functions, now and random, we can check the final result of this whole function ID. Let's switch back to the test file and see what this function is going to return now. So it always returns string 1s. And this is what we're going to check. I'm gonna call expect and check the return value, comparing it with 1s string, like so. And the test is passing, but if we will comment out either of these spy-on method calls, test is going to fail, because in this case, function ID depends on the random value generated by the random function of the mass object. So the reason we have mocked both of these functions now and random is that these functions are provided by JavaScript itself, which means that we haven't written those functions and we don't have to test them. We only have to test our code that we wrote ourselves. And by making the function ID not be dependent on the current time or any random number, we were able to check return value of this function. Also regarding mockReturnValue1's method call, which we will mock return value of some function only once. For the one method execution, there is also another function called mockReturnValue, which mocks return value of the function forever, regardless of how many times we would call that function. But in this particular case, mocking the return value only once worked for us. Link to the source code of this lesson will be in the video description. Moving on to the next file with functions, it will be router.ts. In here we have a function with the name normalizePageHash, which is a pretty interesting use case for us to test, because this will be different from all other tests we have written before. Because as we can see in here, we are referencing object called Windows, which only exists when this function is executed in the browser environment. So we will have to find a way to provide this object in a Node.js environment to be able to test this function. We're going to talk about implementation details of this function a little bit later, and for now, let's create a new file with tests where we're going to write scenarios for functions inside router.ts. The first thing, as always, I'm going to import function it from the Vitest library and describe a couple of testing scenarios. The first scenario will be testing the function normalizePageHash when we're going to provide valid page hashes. And the second scenario is going to test that same function, but in this case we're going to provide invalid page hash. So now let's consider in more details the implementation of the function we're about to test. The idea of this function is to extract page hash from the address bar, and in case the page hash is invalid, this function is going to replace invalid hash with a valid one. Let's say we have our application running on localhost on the port 5173, and the hash determines which page should be initially opened. For example, if we'll specify timeline, that means timeline page should be opened. In our particular case, there are only 3 valid page hashes. All of them are described by this enumeration page name. So the valid hash can only be equal to timeline, activities, or progress. So if we're going to provide valid page hash, that means we're going to get into this if conditional, and eventually this function is going to return valid page hash, extracted out of the hash from the address bar. But let's say if we'll provide invalid page hash, we're going to skip this if conditional and execute the rest of the code where we're going to reset invalid page hash by assigning valid page name, in this case timeline, to the hash, and eventually we'll return valid page name. Actually, this function has been taken out of the context, and it might not be fully clear, but to us it doesn't really matter that much in order to test this function. So let's just start writing implementation for our tests. But the moment I'm going to call normalizePageHash function from within the test, in the terminal we're about to get such error. That is because all tests are executed in Node.js environment, which doesn't have window object. This is exactly what the error is saying because we were referencing window object on this line, trying to fetch hash of the page. So for such cases, in order to test those functions that are dependent on some browser APIs, like in our case, we need access to the window object. We have several libraries which allow us to mock browser environment in the Node.js environment by providing all objects available in the browser. So I'm going to go with HappyDOM library to mock browser environment. First things first, let's copy over this command to install this library. I'm also going to use flagD because this dependency is only going to be needed during testing and not gonna be used in our production code. Once this is installed, in order for us to specify which environment Vitest should use to execute our tests, we just have to place the following comment at the beginning of the testing file: Vitest environment followed by the name of the library we used to mock browser environment. So after doing this, if we'll check tests again, this time we didn't get that error. That is because window object is now available, and if we're gonna print this object in the terminal, we're going to see this output with all available methods and properties on the window object. So now let's think how we can test normalizePageHash function. The first thing what this function is doing is it tries to extract the hash of the page. So we have to kind of arrange the world before executing this function and assign some string to the hash property of the location object. So in here I'm going to assign valid page name timeline to the hash property like so. As a reminder, valid page name can be one of the following three values: timeline, activities, or progress. And then we'll just have to compare the return value of the normalizePageHash function with the hash that we expect. In this case, we're expecting it to return timeline hash. Since timeline is valid hash, normalizePageHash function is not going to reset it. In order to avoid running any other tests, I'm going to specify only modifier to run only this one test, and it passed. So when we assigned valid page name to the hash, we ended up inside of this if conditional, and eventually this function has returned valid page hash. Just in case, I'm going to return invalid string in here to make sure that tests will fail in this case. So by executing this expression, we iterated over all objects inside of nowItems array and checked values inside page property and compared each value with provided hash. And if any page value matches the hash, that means the page hash is valid. So since we have three valid page names, I'm going to duplicate these lines a couple of times and use different valid page hashes. In the second case, I'm going to use activities page name. And in the third one, let's use progress, because those are all valid page names and the test should pass. But it's also a good idea to keep our tests clean and also from time to time do refactoring. So for example, in order not to repeat those two strings 3 times, we can iterate over page name enumeration by using values method on the object like so. This way, on each loop iteration, we're going to get page name from the enumeration in the page parameter. And then we're gonna use this parameter instead of hardcoding page name. Right here. So we're gonna do the same thing, but this time it's a little bit more concise. So let's remove these other extra lines and check test execution again. All tests have passed. But we also have to make sure that when assigning valid hash to the hash property, this function is not going to reset it because we will not reach this line. So I'm going to add an extra expectation right here and check that the value of the hash property should be equal to the initial page value that we have assigned to the hash before executing normalizePageHash function. So now it's time to write an implementation for the second testing scenario. We're going to test the same normalizePageHash function, but in this case we're going to supply invalid page hash before executing normalizePageHash function. So this way we're going to check the second part of this function, followed by if conditional. The implementation will be pretty similar, so we can copy over the body of the first test, paste it in here, and instead of assigning valid page name, we're going to assign any string which is not valid page name. In this case, normalizePageHash function should reset invalid page hash and assign valid page name, which is timeline. We're checking both cases that normalizePageHash function will return string timeline as well as value of the hash property should be equal to timeline. Now before checking test results, let's remove the only modifier in order to run all tests. They are all passing. But if we're going to modify initial function in some way, and instead of assigning timeline to the hash, we're going to assign name of the activities page, right away we're going to get an error after running tests. Before finishing this lesson, let's just improve the implementation of this test function a little bit by using enumeration instead of hard-coding strings. So in here I'm gonna reference timeline element of the page name enumeration instead of using timeline string in both cases. Now let's take a look at the test results one last time in this lesson to verify they're all passing. Link to the source code of this lesson will be in the video description. Let's move on to the next file we're going to test. It's called time.ts. We'll start testing this file from the function called today. It has a very simple implementation, and all it does is it returns newly created date object which corresponds to the current date. Just like we have done several times before, let's create new file with tests called time.test.ts. Firstly, let's import function it from the Vitest library and describe our first testing scenario. So we're going to test the function which is supposed to return the current date. Then there is another pretty similar function to the first one called tomorrow. And as you may have guessed, this function returns date of tomorrow. Let's mention this fact in the second scenario. It gets date of tomorrow. The next function is called end of hour. And what this function is doing is it returns that same date, but the hour will be incremented by 1. Let's say the current time is 8:30 p.m. Then passing this date to this function is going to return the date which corresponds to 9 p.m. The next function is also pretty simple. It allows us to determine whether the past date is today. So we're going to verify that this function also behaves as expected. It checks if past date is today. And finally, the last function in this file is called toSeconds. And this is basically a conversion function, so it simply converts amount of milliseconds into amount of seconds. And now that we have defined all testing scenarios in this file, let's start writing implementation for the first testing scenario. It gets current date. So let's prepare all necessary data we need to test the function. We'll create date object with any date. And in the third part of the test, where we usually write our expectations, we'll call function today that we are testing, and we expect that this function will return previously defined date. But of course, it's going to fail right now because the current date is different. And we can't actually rely on the current date in our tests, because depending on when we're going to execute the test, current date will always be different. But we always have to keep our tests predictable. And sure enough, if we're going to execute our test now, we'll see differences in dates. So to test functions that depend on the date and time, Vitest provides us with a way to specify system time. So basically we can mock system time to set this time to whatever date we wish. And we are mocking the current date and time by calling setSystemTime method on the VI object. Let's just import this object up above and check the test again. This time it has passed. So what actually happened here is this. Before calling setSystemTime, if we're gonna create dates, anytime we're going to get new date object, even if only milliseconds or seconds are different. But to make it more clear, I'm going to implement fake delay by using promises. So let's just create new promise, and then by using setTimeout call, we can defer this promise to be resolved in 2 seconds, like so. And since we have used await inside of this function, we also have to specify async in front of it. And now let's use this fake delay in between these console log statements. And just to wait less, let's use 1 second instead of 2. And there we go. As you can see, every date has different amount of seconds because we have used 1 second delay in between every console log statement. But watch what happens if we're going to call setSystemTime before any of these console log statements. Let's see what happens with the date objects. And interestingly enough, we have the same date object printed 4 times. And the test has passed. That is because we have set system time to be equal to the date stored inside date constant, which is why this expectation has passed. Alright, now let's do the following. I'm going to create 3 different date objects and call them date A, date B, and date C. And I am just picking these dates randomly. So first of all, we're going to mock system time and assign date A to be the current date and time, and then we'll check if the function today is going to return this date. Then we're gonna do the same with the second date, date B, followed by expectation that function today is going to return new current date, which corresponds to the date stored inside date B constant. And the same thing we're going to do with the third date, date C. And there we go, everything has passed. By the way, we don't need this async keyword in front of this function, since this function doesn't have any asynchronous calls. And also let's remove this only modifier, so that we don't forget to check all tests at the end of the lesson. Another important thing is that whenever we are mocking system time, at the end of the test, we actually have to restore the original current date. And we're doing this by calling useRealTimers method on the VI object. Because if one test sets different current time, all other tests will also be affected, because we are modifying global state by setting new current time. So if we wouldn't call useRealTimers, today function call would return the last mocked date that we have set in the test. But if we'll call useRealTimers, then the function is going to return proper current date, which is correct in my case. And at the end, let's run all tests in the project. All of them are passing, so we can move on to the next lesson. Alright, so we have worked with dates quite a bit in the previous lesson, and now we'll continue. Let's start writing testing scenario for the function tomorrow. To test this function, we're going to prepare 2 pieces of data. In particular, we need current date as well as date of tomorrow. So I'm going to create 2 date objects. And again, I'm picking dates randomly, but it's important that date of tomorrow should be actually the next day in relation to the first date. And down here, we're going to write an assertion and check that function tomorrow is going to return the date stored inside of tomorrow constant. Actually, we can't have same names for variables and functions, so I'm going to rename tomorrow and tomorrow date and import function tomorrow from the time module. So to be able to test function tomorrow, which also depends on the current date, we'll have to fake current date, just like we have done in the previous lesson by using setSystemTime call. We're gonna use the same call in here and pass date object to set this date as current one. If the current date is stored inside date constant, we're gonna get this test passing. Let's run only this one test by using modifier only. And there we go, it is passing. But of course, if we'll try to call tomorrow without mocking the current date, we're going to get a different date, which is a real tomorrow date. But we cannot rely on real dates in our tests, because then our tests will depend on dates, which is not good. Now let's repeat the same process a couple more times. I'm going to rename date on date A and tomorrow on tomorrow A. And then let's duplicate these two lines 2 times. Here we'll have date B as well as tomorrow B. And finally, in the third case, we're gonna have date C as well as tomorrow C. And then let's appropriately change dates. Dates for date B and date C constants can be picked randomly, but dates stored inside tomorrow B and tomorrow C should be tomorrow dates, assuming that the current date will be date B or date C respectively. So we'll just use same lines 3 times to check each of these dates. In the first case, we're checking date A. We are setting the system time to be equal to date A, and then we're testing that function tomorrow is going to return tomorrow date stored inside tomorrow A constant. And same goes with all other dates. In the second case, we're checking date B. So before we are setting the current time to be equal to date B, and then checking if tomorrow function is going to return date stored inside tomorrow B constant. And finally, in the third case, we're doing exactly the same for date C. And of course, as was mentioned in previous lesson, anytime we're mocking current date, it's a good idea to reset current date at the end of the test, which we can do by calling use real timers in here. So let's just use our statement to simulate delay that we have written in the previous lesson. Let's make this function asynchronous and use promise in here to defer function execution by 1 second. And regardless of how long we will wait, since setting current date and checking function tomorrow, the test will always be passing because it doesn't depend on the current date, since we have mocked it and manually specified what current date should be equal to. And with that, we're finishing with test implementation for the function tomorrow. Let's remove only modifier and check execution of all tests in the project. They are all passing. Link to the source code of this lesson will be in the video description. Moving on to the next testing scenario. This scenario will test function called end-of-hour. And what this function is doing is it basically accepts a date object. Let's say we have passed a date with a time of 8:30 p.m. and this function will basically return the same date, but an hour will be changed to the next one. So instead of 8:30 p.m., it will contain 9 p.m. but the date itself will remain the same. And also please note that this function does not modify the past object, but instead it creates new date object. So in the first part of the test, where we're preparing the data, we're gonna create two date objects. First one we're going to pass into end-of-hour function, and the second object will be the one we're going to compare the result with. And since our first date object has time of 10:15 AM, the second one should have time 11 AM. So besides incrementing an hour, it also drops amount of minutes. So now in the third part of the test, I'm going to write an expectation, call the function end-of-hour, and pass first date object. And then I'm going to compare this result with the date stored inside end-of-hour constant. But the thing is that end-of-hour constant is called the same as end-of-hour function, so we have to rename the constant. I'm going to use end-of-hour date. And if we're going to take a look at the test results, sure enough we'll see that the test is passing. But the moment I'm going to change an hour of the second date, for example, let's use 12, right away we're going to see an error in the terminal. Let's revert this change and try to modify implementation of end-of-hour function to make sure that if implementation is broken, test is going to let us know about it. This test is still failing, so it's good. Now I'm going to go back to the test file and add a couple more date objects. So we're going to have date A, date B, and date C, and corresponding end-of-hour objects to compare results with. In here I'm using random dates for objects date B and date C, and end-of-hour constants should contain those same dates, but with hour incremented. If the date B object has 8 PM, the end-of-hour B object should have 21 PM. And if date C object has 12 PM, the end-of-hour C object is supposed to have 1 PM. Let's duplicate this expectation and use it 2 more times. In the second case, we're passing date B and expecting end-of-hour B, and lastly, we're passing date C and expecting end-of-hour C. And all our expectations have passed. Moving on to the next testing scenario. It checks if past date is today. So this testing scenario is going to be used to test function with the name isToday. This function accepts date object, and it basically checks if the past object corresponds to today's date. So for this test, we're gonna need only one piece of data. I'm going to declare date A object, which is going to be a random date. And then to make sure that isToday function works properly, I'm going to expect that the return value of this function is supposed to be equal to false, because the date stored inside date A object isn't the current date. And the test is passing, but what if we're going to mock the current time by using setSystemTime function and passing date A object? In this case, date A is current date, so isToday function is going to return true. And because of this, our current test fails. So in here, let's change this value on true. And to have some extra guarantees, I'm going to create another date object, date B. Let's also use a random date for this one, and duplicate this expectation. Instead of date A, we're passing date B into isToday function and expecting the result to be false, since it is not the current date. So the test is passing. Now I'm going to copy these 3 lines, paste it one more time at the end of the test, and here I'm gonna do the opposite. I'll set system time to be equal to date B object. Then in the first case, we're expecting that isToday function is going to return false, and in the second case, when we're passing date B to isToday function, it is supposed to return true. And of course, since we have mocked current date in this test, we have to reset it at the end. So let's use real timers in here. Just to be extra sure, let's modify implementation of isToday function. Instead of comparing the date with the current date, I'm going to compare the past date with tomorrow's date. In this case, test is supposed to give us an error. And as we can see, it's throwing an error. So now I'm gonna revert this change, get back to the test file, remove the modifier only, and now we're getting to implementing the last testing scenario in this file. This scenario is going to test function with a name toSeconds. The purpose of this function is pretty simple. It just takes amount of milliseconds and converts them into seconds. As you can see here, we have a simple formula for conversion. So get back to our test and write expectation. I'm gonna call it toSeconds function, passing minus 10,000 milliseconds. In this case, the function is supposed to return minus 10 seconds after conversion. And then I'll add a couple more expectation. In this second case, let's pass minus 1000 milliseconds. We'll get minus 1 second. And let's also use 0. In this case, we're also going to get 0 back. So all these expectations are passing, but if we'll change implementation of toSeconds function, we're going to see them failing. Now I'm gonna revert this change, get back to the test, and add a couple more expectations. In the fourth case, we're passing 1000 milliseconds and should return 1 second. And lastly, after passing 10,000 milliseconds, we're about to get 10 seconds. And all expectations are passing. At the end, let's also run all tests. I'm gonna remove modifier only and check results in the terminal. As you can see, all tests in the projects are also passing. Let's continue in the next lesson. In this lesson, we will start writing tests for functions located inside TimelineItems.ts. And the first such function will be updateTimelineItem. So let's create new test file called TimelineItems.test.ts inside test folder. Here as always, I'm going to import an init object from the Vitest library and declare the first testing scenario. It updates TimelineItem, which is supposed to test function called updateTimelineItem. Before writing actual implementation of tests, we'll add all scenarios we're going to test. So the second scenario will be used to test the function with the name resetTimelineItemActivities. So right here I'm gonna duplicate this line and change description of this scenario. It resets TimelineItemActivities. Then there is also this function calculateTrackedActivitySeconds. We'll add testing scenario for this function as well. And that's all. Now let's start writing implementation for the first testing scenario. Let's remove this modifier to-do and replace it with only. Alright, so before writing implementation, let's see what updateTimelineItem function is doing. It basically accepts TimelineItem object and another object with updated values for fields of TimelineItem object. And then we're basically calling this method assign to assign values of fields object to fields of TimelineItem object. As you may remember, several lessons back, we have already created tests for similar function, but in that case that function was used to update activity objects. So we can actually copy over the testing scenario for this function. Let's do so right now and paste it into our new test. But of course here we are dealing with TimelineItem objects instead of an activity object. I'm going to rename this constant on TimelineItem. And by the way, TimelineItem objects have such structure. They have 4 fields: our activity ID, activity seconds, and isActive. So now we're going to add proper structure to TimelineItem object right here. But before, let's also change the type of the second constant on TimelineItem. So we are supposed to have 4 fields in this TimelineItem object: field hour, activity ID, activity seconds, and isActive. And for now I'm assigning random values to these properties. And then for the second object, updateFields, I'm going to use same set of properties. But in this case, these properties should have different values, since this is the object we're going to use to update the first object. And then down here, we're going to call the function updateTimelineItem and accept the result into updateTimelineItem constant. So let's call the function we're testing right here, updateTimelineItem, passing TimelineItem object as the first parameter. This is the object we're about to update. And finally, after executing updateTimelineItem, we should expect that TimelineItem object was mutated and now equals to updateFields object. Because updateTimelineItem function not only returns updated object, but also modifies the source object passed as the first parameter into that function. And sure enough, this test is passing. What if we'll try to use toBe matcher instead of a toEqual? What will happen in this case? The test is failing, because matcher toBe compares references of TimelineItem object with updateFields object, and these are two different objects, so they have different references. In this case, we have to use toEqual matcher to compare values of individual properties of these objects. To be extra sure, let's also check what is going to happen if we're gonna pass TimelineItem object as a second argument in here. So in this case, we're technically reassigning values of TimelineItem object to the properties of that same object. So basically, we're not doing any updates. And sure enough, the test is going to fail in this case, because none of the properties of TimelineItem objects were updated. Let's revert this change, remove modifier only, and in the next lesson we're going to get to writing test implementation to the second testing scenario in this file. Link to the source code of this lesson will be in the video description. Moving on to the next scenario, as always, first thing we're doing before writing implementation for the test is we're checking what the function is actually doing. In this case, the function resetTimelineItemActivities takes a couple of arguments, first of which is array of TimelineItem objects, and the second argument is activity object. And then this function is going to iterate over TimelineItem objects of the array, which is passed as the first argument, and reset a couple of properties of these objects, such as activity ID as well as activitySeconds. But only then if the current TimelineItem object is related to an activity passed as the second argument. Later on, we're gonna take one more look at the implementation of this function, and now let's start writing test implementation. Since for this test we're going to need activity object to be passed as the second argument, we can copy over this object from another test and paste it in here. Actually, in this case, it will be better if we're going to declare a couple of activity objects. I'm gonna call the first activity object trainingActivity, and the second one will be called readingActivity. And I'm also going to change values of all fields of the second activity objects to make them different. Besides these two objects, we're also going to need an array of TimelineItem objects. So I'm gonna create an array TimelineItems. In here, we have to add objects with 4 properties, what TimelineItem type requires. And I'm basically going to relate first TimelineItem object to trainingActivity by assigning ID of this trainingActivity to activity ID property like so. And then let's add a couple more TimelineItem objects in this array. The second object will also be related to trainingActivity. Just to make these objects different, I'm going to change values of properties. And finally, the third TimelineItem object is going to be related to another activity, readingActivity. So moving on to the second part of the test, where we're going to call the function we are testing, which is resetTimelineItemActivities function. And since this function requires 2 arguments to be passed, we're going to pass TimelineItems array as the first argument and trainingActivity object as the second one. And just to fix this TypeScript error, let's just explicitly specify the type for TimelineItem's constant. It contains an array of TimelineItem objects. And now let's take one more look at the implementation of the function we are testing. So basically in here what we are doing is, firstly, we are filtering an array of TimelineItem objects passed as the first argument, and keeping only those TimelineItem objects that are related to the activity object passed as the second argument. And then, in this loop, for each TimelineItem object which is related to the activity passed as the second argument, we're going to reset activity ID as well as activitySeconds property. But we are resetting activitySeconds property if current hour does not equal to the hour stored inside our property of TimelineItem object. Otherwise, we're basically going to reassign value of activitySeconds property to itself, which means we're not doing anything. So in our particular case, since first two TimelineItem objects are related to the activity we're passing as the second argument, in this case we're going to reset activity ID properties of these objects and set it to null. And same goes with activitySeconds property. But also we're going to mock the current time and set such time where the current hour will be equal to 2, which is the value stored inside of our property of the second TimelineItem object. In which case, activitySeconds property of this object should not be restored back to 0. Alright, before getting to expectations, let's scroll up and create new date object, which is going to be used to mock the current date and time. In here we're calling setSystemTime, passing this date object to mock the current time. Of course, VI object has to be imported from the Vitest library. And also please note that for this object I have used toPM, which is exactly an hour that we have assigned to the hour property of the second TimelineItem object. So down here let's write our expectation and check that TimelineItems array, which was passed as the first argument into resetTimelineItemActivities function, should be equal to another array. As a starting point, I'm going to copy over all these TimelineItem objects, paste them right here and change a couple of values that we expect to be reset. The first object is going to have a couple of properties reset, such as activity ID, as well as activitySeconds. The second TimelineItem object is going to have activity ID property also reset, but activitySeconds property should remain the same, because these TimelineItem objects corresponds to the current hour we have previously mocked. And the third TimelineItem object is not going to be modified at all, because it is related to a different activity than that we have passed to resetTimelineItemActivities function before. And just to make it extra clear that the second TimelineItem object corresponds to the current hour, I'm going to call the method getHours on the date object to extract the current hour of the current date. And the same thing I'm going to do right here, calling method getHours. But also to fix this TypeScript error, we have to explicitly cast this value to the hour type, like so. And this hour type is basically a union of 24 integer numbers from 0 to 23. So all these numbers correspond to valid hours. Let's also not forget that since we have mocked the current time, at the end of the test, we have to reset the time by calling useRealTimers method. And there we go, we're seeing that our test is passing. I'm going to switch back to the file with implementation of this function and comment out one property. In this case, the test is going to give us an error, because activity ID property, as we can see, was not reset. The same result we're about to get after commenting out the second property, activitySeconds, and now activitySeconds property is different. So we know that the test is checking the right thing. At the end, I'm going to remove modifier only to run all tests in the project. All of them are passing. Link to the source code of this lesson will be as always in the video description. Finally, we are left with only one testing scenario which is not implemented yet. So now let's take a look at the function we're about to test. It's called calculateTrackedActivitySeconds. In this case, it takes two arguments, first of which is array of TimelineItem objects, and as the second argument this function takes object of activity type. So the arguments of this function are pretty similar to those we were passing to the function that we were testing in the previous lesson. So I'm gonna switch back to the test file and copy over this code from the previous test. Then I'm gonna paste this code into our new test. I'm gonna change a few things in here. For example, we're not gonna call getHours method on the date object to get the current hour. Instead, we'll basically use to, since for this test, this hour will not matter. Now let's call the function calculateTrackedActivitySeconds and pass necessary arguments. The first argument is array of TimelineItem objects, and the second one is an activity object. So let's pass TimelineItems array, as well as one of the activities. I'm going to pass trainingActivity. And eventually this function is going to return only one value, which will be the sum of values of ActivitySeconds fields. But only those fields that belong to TimelineItem objects that are related to the activity we have passed as the second argument. So since in this case we have passed trainingActivity as the second argument, we're going to sum up value of this ActivitySeconds property and the value of ActivitySeconds property of the second object, since this object also belongs to the same activity. And we're going to ignore the third object, because the third one belongs to a different activity. So moving on to expectations, let's expect that tracked ActivitySeconds number will be equal to another number, specifically to the sum of 3600 and 1800 seconds. So we are expecting that tracked ActivitySeconds constant will store value of 5400 seconds. And just to make it clear, let's take one more look at the implementation of calculateTrackedActivitySeconds function. So after we have passed TimelineItems array into this function, it is going to filter down this array to contain only those TimelineItem objects that belong to a particular activity, in this case to that activity we have passed as the second argument into this function, and then it calls method map on the array of TimelineItem objects and extracts ActivitySeconds property of every TimelineItem object, and eventually it is calling method reduce to sum up all the values of ActivitySeconds properties. And eventually we're seeing that the test is passing. Now I'm going to rename this constant on TrackedReadingActivitySeconds, because I would like to call this function calculateTrackedActivitySeconds also for the second activity. So we're going to have the same colon here and the same assertion. Actually, let's rename the first constant on TrackedTrainingActivitySeconds instead of a reading. Here we're going to expect that the value stored inside TrackedReadingActivitySeconds equals to amount of seconds inside ActivitySeconds property of the third TimelineItem object, because this is the only TimelineItem object which belongs to the reading activity. And yes, test is failing now, because I forgot to pass proper activity object as the second argument into second call of calculateTrackedActivitySeconds function, because here we're calculating ActivitySeconds of a reading activity. And after doing this change, test is going to pass. To be sure we're testing proper behavior, I'm going to change implementation of this function. For example, let's use minus instead of a plus. In this case, we have gotten a negative value, which is not correct, so test is throwing an error. Let's revert this change, get back to the testing file, remove modifier only to check all tests in the project. All of them are green. So we are ready to move on to the next lesson. The link to the source code will be in the video description. In this lesson, we're going to try to improve readability of our tests by using constants, because currently there are lots of hard-coded values that we are using in our tests, and it would be good to use readable names instead of random values. Let's start with activities.test.ts. Right here for the seconds to complete property, we're using 3600 seconds. But to make it clear that this amount of seconds corresponds to 1 hour, I'm going to replace this value with usage of constant seconds an hour. And all the constants that we are going to use are defined inside constants.ts file. So in here we could leave it as is, but I actually prefer to also multiply this constant by amount of hours. This way we are clearly seeing how many hours this amount of seconds represents. And I'm going to follow similar approach when replacing other hard-coded values. For example, in this case, we're going to multiply seconds in hour by 2, since 7200 seconds correspond to 2 hours. In the third case in here, we're also using 3600 seconds, which is 1 hour. So I'm going to multiply seconds in hour by 1. And as for the values that we are passing as the second argument into calculateActivityCompletion% function, in every expectation in here, we'll also represent those as an expression by multiplying seconds in hour constant by appropriate coefficient. So in the first case, we have to pass 0 amount of seconds, so I'm gonna multiply seconds an hour by 0. In the second case, we have to pass 1800 seconds, which we can get by multiplying seconds an hour by 0.5. And finally, to pass 3600 seconds, we're going to multiply seconds an hour by 1. And as for the value which represents 100%, we also have a constant called 100% for such cases. So I'm going to replace 100 with this constant 100%. Moving on to the next file with tests functions.test.ts. In the first test, we're seeing that we are using a bunch of expectations, and we are passing different hard-coded values into every call of formatSecondsWithSign function. So I'm gonna represent all these values by using expressions with the constant. So in the first case, I'm going to multiply seconds in minute constant by 0 to get 0 seconds eventually. And as we can see, seconds in minute constant holds value of 60, amount of seconds in 1 minute. This way we'll clearly see how many minutes we are passing into this function. So in the second case, we're going to multiply seconds in minute by 1, since in here we have to pass 60 seconds. In the third case, we're gonna have to pass amount of seconds which corresponds to 3 minutes. So I'll multiply this constant by 3. In the fourth case, we have to pass 1800 seconds. So I'm multiplying seconds in minute by 30. In the next case, it will be a little bit different, since we'll already have a constant which holds amount of seconds in 1 hour. So I'm basically going to use this constant. And finally, in the last case, we're doing this multiplication to obtain amount of seconds in 1 day. But fortunately, we already have a constant which stores this value. It's called seconds in day. So let's replace this expression with the constant. Moving on to the next set of expectations. These expectations are pretty similar to previous ones, with the only difference that in here we are passing negative amount of seconds. So what we can do in here is basically do the same replacement and use same expressions, but in front of every such expression, we're basically going to prepend minus to get negative values of seconds. As for the next test, which tests function called formatSeconds, We also have a pretty similar expectations to those used in the previous test. So I'm going to copy over this set of expectation from the previous test, paste it into the next one, and then all I will have to do in here is to replace formatSecondsWithSign function with formatSeconds. Then we can remove previous expectations, and we also have to remove the sign from every string that we are using to compare resulting value with. And the beauty of having tests is that whenever we're gonna make a mistake, we'll just have to take a look at the test execution to see whether we have broken anything or not. In this case, everything is okay, all tests have passed, so we can continue with our refactoring. The next test we're gonna work on is located inside time.test.ts. Let's scroll down to the very end of this file, and right here, when we are testing toSeconds function, we're passing amount of milliseconds into every call. I would replace those so-called magic numbers with expressions to make this test a little bit more readable. So how can we represent 10,000 milliseconds? By using one of the available constants. We can do so in the following way. Let's multiply milliseconds in second constant, which holds amount of milliseconds in 1 second, by 10. And also, by preappending minus in front of this expression, we'll get minus 10,000. And now let's do same replacement for other cases. In the second case, we're gonna multiply milliseconds in second by 1 to get value of 1000. In the third case, we have to pass 0 milliseconds. So to get 0, we just have to multiply this constant by 0. And the next two expressions will be very similar to previous ones. In the first case, we're multiplying this constant by 1 to get 1000. And finally, to get 10,000, we'll have to multiply milliseconds in second by 10. Before moving on to the next test, let's make sure that all tests are green. And they are. Let's go into the next file, timelineItems.test.ts. In here, I'm going to replace hard-coded values with constants, just like we have done in the previous files. So for this ActivitySeconds property, we have to use 0. So let's multiply seconds in hour by 0. For the next one, to get 3600 seconds, we'll have to multiply seconds in hour by 1. In the next case, it will be the same expression, seconds in hour multiplied by 1. Next, to get 7200, we have to multiply seconds in hour by 2. And to get 1800 seconds, we have to divide seconds in hour by 2, or, in other words, multiply by 0.5. There are actually quite a bit of such hard-coded values in this file. I'm going to speed up the video and quickly replace all such occurrences with expressions, following the same principle. And finally, for these two expectations, let's also represent amount of seconds by using expression. To get 5400 seconds, we have to multiply seconds in hour by 1.5. And to get 3600 seconds, we'll need to multiply seconds in hour by 1. And with that, all our tests are passing, and we were able to improve their readability. Link to the source code of this lesson will be in the video description. In this lesson, we're going to review one technique to group related tests together. So let's review on the example of the first test from activities.ts.ts file. As a reminder, in here we are declaring a couple of objects, first of which is an activity object, and the second one, an object with the fields that will be assigned to the fields of the first activity object. After, we're gonna call this updateActivity function, and as you can see in here, we're using two expectations. The first one checks whether initial activity object was mutated, and the second expectation checks whether updateActivity function has returned expected value, which is updated activity object. And there is a recommendation when writing tests. it's good to use only one assertion or expectation in one testing function. But of course, it is not the hard rule, there are always exceptional cases. But as a general guideline, it's good to stick to this rule and use only one expectation in one testing function. It will allow us to find errors easier. For example, let's consider another test from the functions.test.ts. In here, we're using lots of expectations, but all those expectations are pretty similar. We are just changing input values, but the logic remains the same. So all these expectations test same aspect of the function, but with different values. In those cases, these expectations are fine to keep in one test. But as for our test, these two expectations test different aspects of the function. The first expectation tests mutation of the original object, and the second expectation tests return value. So in this case, I'd prefer to split this test by 2 and place every expectation into its own testing function. So I'm going to copy over this testing function, paste it down here, and then let's also change descriptions of these functions to better reflect what these tests are testing. The first test is going to ensure that the original activity object is updated, or in other words, mutated. So in here we don't need to use expectation that checks return value of the updateActivity function, so I'm gonna remove this expectation along with the constant which holds return value, because we're going to check whether the function returns correct value in the second test. So in here I'm gonna remove expectation which tests if the original activity object was mutated, and keep only the one which tests return value. By the way, we don't need to create temporary variable to hold return value of the updateActivity function, since we can inline this function call and put it in here right into expect function. And eventually we'll end up with such structure of this file, where we have 3 tests, where first 2 tests the same function. And in those cases, sometimes it might be useful to group such tests that test one function. And to group related tests, we can use function called describe. I'm gonna call this function in here. As the first argument, we're passing the description of the set of tests we are wrapping into this describe block. And as the second argument, we're passing the function where we're placing our tests that we'd like to group together. We gotta import function describe from the Vitest package. Then let's see what's common between these two tests. Every test declares an object updated fields, so it makes sense to reuse this object for both tests. So we can extract this object from here and paste it directly into the closure of the describe function. And then we can remove this object from individual tests. This way we are reducing duplication in tests. And by the way, this activity object is also the same in the first and the second tests, but let's not extract it yet, because there is one thing related to this object that we're going to review in one of the next lessons. And now in the terminal we're going to see that those tests that belong to one describe block are grouped together under same heading. And by the way, all those modifiers we have previously used when calling function it, such as only or skip, they also can be applied to describe blocks. For example, if we want to run only tests from a particular describe block, we just have to use only. And now these two tests were executed, but the last one, which does not belong to this describe block, was skipped. And vice versa, if we want to skip all these tests from the describe block, we have to use skip. And this time, only one test was executed, which doesn't belong to the describe block. Now let's try to practice using describe block a little more. So inside functions.test.ts, we can split the first test by 2. Since first set of expectations checks if the function formatSecondsWithSign works properly when passed positive amount of seconds, but the second set of expectations ensures that these functions works properly when we pass negative amount of seconds. So I'm gonna copy over this whole test, paste it down here, and in here I'm gonna just keep those function calls where we're passing negative amount of seconds. And just to improve the description of this testing scenario, I'm going to rename description and say it formats negative amount of seconds, like so. As for the first test, in here I'm gonna use almost the same description, but instead of a negative, I'm gonna use positive. In this test, we will only keep those calls of formatSecondsWithSign function that accept positive amount of seconds. And now that we have two testing scenarios which test same function, we're gonna wrap these two tests into describe. Let's not forget and import function describe from the Vitest package and assign description to this describe block. And whenever we are grouping several tests that test the same function as a description, we can use the name of the function that we are testing. In this case, the function name is formatSecondsWithSign. In the terminal, we're seeing all tests are passing, and two tests were grouped under same heading, formatSecondsWithSign. Let's also check what is going to happen if we will intentionally make a mistake in one of our tests. And test runner shows us exactly the test case which has failed. At the end, let's run the whole test suite in the project and make sure that all tests are passing. Let's continue in the next lesson. Link to the source code will be in the video description. Inside TimelineItem.test.ts, there is a pretty similar test to the one from the activities.test.ts. It's this one which tests updating activity. But as you can see in here, we have two different expectations. And just like we have done for the activities test, we can split up this test by two to keep only one expectation into every test. So I'm gonna go back to activities.test.ts. In here we have previously split up this test by two. So I'm gonna copy over this describe block, move it into TimelineItems.test.ts. Of course, in the description for this describe block, we will mention that we are testing the function called updateTimelineItem. And now let's copy the first test and paste it down here inside the describe block. Now let's change the descriptions of both of these tests to better replicate what these tests are actually testing. The first test is going to ensure that we are mutating the original TimelineItem object while calling updateTimelineItem function. And the other one is going to check that we return proper value from the updateTimelineItem function. And now I'm going to extract the common parts from both of these tests, such as this updated fields object. It is present in both tests. So I'm going to move it up here inside describe block. Then let's remove the declaration of this object from the first test, as well as this constant which accepts return value of the updateTimelineItem function. Since in this test we're not going to check return value, we are only keeping one expectation to ensure that updateTimelineItem function is going to mutate original TimelineItem object. And inside the next test we're gonna do the opposite thing. Here we are removing the first expectation and checking only return value of the updateTimelineItem function. By the way, these two lines can be combined by inlining updateTimelineItem call, like so. And there we go, all tests are still passing, but now we are seeing that the first two tests were grouped under the same heading by using the describe block. Moving on, and now we're going to use another describe block inside TimelineItem.test.ts to group remaining two tests. Because if we'll take a look at the implementation of both of these tests, we're gonna see a lot of declaration for objects. The preparation part of these tests is pretty big, so it makes sense to extract some of these declarations to not repeat ourselves. And then let's use describe and wrap these two tests And as a description for this describe block, I cannot use name of the function because these tests are testing different functions. So I simply use name of the entity that we are testing in here, timeline items. And now it is time to extract repeated declarations from both of these tests. We can move these two objects, training activity as well as reading activity, outside of the test and put them inside the describe block. Next, let's remove declarations of these objects from the second test in this describe block. And this way we were able to reduce duplications in this file by using describe block and moving common functionality outside of testing functions. So by now we have two describe blocks in this file, each of which contains two testing scenarios. As we can see, all tests in this file are passing. Let's also make sure that all tests in the projects are passing as well. And they are. So we can continue working on tests in the next lesson. Link to the source code of this project will be in the video description. Let's open up the file with tests called activities.test.ts and take a look at the first test. Since we have moved common functionality outside of these tests and put it in the describe block which wraps these tests, there is also another piece which is pretty similar, which we can also extract. It is this declaration of activity object. We can see it in the first test as well as in the second one. And now let's remove declaration of this object from the second test and see if our tests are still passing. So far so good, but in fact we have the same declaration of this object inside the last test in this file. So why don't we reuse the same activity object for all tests in this file? Let's try it out. I'm gonna remove this declaration from the last test. And to be able to use single activity object for all tests in the file, we have to move this declaration of activity object outside of the describe block and put it at the top level of the file. So it's available in absolutely all test enclosures of this file. But surprisingly, if we'll take a look at the status of our tests, we're seeing that some of them are failing. And specifically, it is the last test of activities.test.ts file. And the reason to that is because when we were calling updateActivity function inside the first test, it has mutated the first activity object that we have passed as the first argument into this function. Which means by the time the second test gets executed, the original activity object will be already mutated and will contain different value inside seconds to complete property, because the first test has modified this property. And this is the reason why these assertions from the last test are failing. So we have to find a way to reset this activity object back to its original property values before executing every test. Unfortunately, Vitest provides us with several hooks where we can run this kind of logic to reset activity object. One of such hooks is called beforeEach. It has to be imported from the Vitest library, and this hook accepts closure as the first argument. And this closure is going to get executed before every test in this file. So I'm gonna move declaration of activity object inside of this closure. And since this closure will be executed more than once, because we have more than one test in this file, I'm gonna have to use normal variable instead of a constant. So let's move declaration of the variable outside. And here keep only the assignment. So now, when we're gonna run tests in this file, this closure is going to be executed once per test at the beginning of every test. Let's make sure that this is really the case. I'm going to output something in the terminal and expect to get this output 3 times, because in this file we have 3 tests. And sure enough, in the terminal we are seeing 3 logs. Besides this beforeEach hook, we also have several others, such as afterEach. It works in the same way, but instead of executing the logic before every test, it executes this closure after every test in this file. So we're still going to see 3 logs in the terminal. but they are displayed after execution of every test. In addition to these hooks before each and after each, we also have before all and after all. And these hooks are different from the previous two in the way that they are not executed once per test at the beginning or at the end of every test, but they are executed only once. Before all hook is going to run the closure only once before all tests in this file are executed, and after all hook is going to run its closure after all tests are executed. Which is why we're seeing only two logs in the terminal, one from before all hook and the other one from after all hook. But besides using these hooks at the top level, we can also put them inside describe blocks. And this way they're gonna be applied only to tests inside the describe block. So to run particular piece of logic only before all tests in a particular describe block, we have to place before each hook inside the describe block, like this. And because we have only two tests in this describe block, we're going to see before each log twice in the terminal. So now that we have solved the problem of resetting activity object before executing every test in this file, let's remove unnecessary imports and check all tests in the project. As we can see, they are all green. Link to the source code of this lesson will be in the video description. There is also a good use case for using before each hook inside TimelineItem's test file. So here inside the last two tests, as we can see, we are defining an array of TimelineItem objects, and this array is the same inside the first and the second tests of this describe block. But we cannot just simply extract this array of TimelineItem objects and move it inside the describe block, because this array is mutated inside the first test. So it is going to affect second test execution, since we're gonna use the same shared array of TimelineItem objects for both tests. Alright, before using before each hook to reset TimelineItem's array before every test execution, let's firstly check if we're going to get an error if we're simply going to move declaration of TimelineItem's array inside describe block. Let's remove this declaration from the first test and take a look at the terminal to see if we're gonna get any errors. And sure enough, we're getting expected error in the last test, because the first test executes resetTimelineItemActivities function, which mutates original TimelineItem's array that we have just extracted into the describe block. So to avoid this side effect, we have to reset TimelineItem's array before we execute each test. I'm going to copy over usage of before each hook from the activities test. And now we basically have to move declaration of TimelineItem's array inside this closure of before each hook. So since the closure will be executed more than once, we cannot use constant because we're assigning value to this variable twice. I'm gonna use let instead of a const to declare this variable and remove constant keyword from here. We are expecting it to execute twice because we have two tests inside this describe block. And sure enough, in the terminal, we are about to see two outputs of before each words. And now all tests are passing. Let's remove this console log statement and move declarations of other constants to the top to group them together with the declaration of the TimelineItem's array. And at the end we've got one before each inside the describe block, which means the logic in the before each is going to get executed once before every test in this describe block. And this is how we are resetting values of objects from TimelineItem's array to avoid any side effects caused by some tests. So all tests from this file are passing, as well as all tests in the project. Link to the source code of this lesson will be in the video description. So far in our project we have several tests with similar assertions. For example, if we'll take a look inside activities.test.ts, scroll down to the end of this file, in here we can see the test, which uses three similar expectations, and in such cases, we can apply one refactoring to make this test to be so-called data-driven. This way we will be able to turn this test into the following, which will have only one expectation, but still it is going to run 3 expectations under the hood, because we are going to create an array with all necessary data needed to run all 3 expectations, but this data will come into this test as parameters. So this way we're splitting the data and the logic of the test. And now I'm going to define a couple of params for this function, call them TrackedSeconds and %. And then to turn this test into a data-driven test, we're going to use method each, which is called on the test object. This test object has to be imported from the Vitest library. Then we will have to build up the array with the data that our test needs, and as many elements this array will contain, as many times our test function will be invoked. So since in our case test function accepts 2 parameters, I'm going to define arrays with 2 elements where first element will be amount of seconds we're about to pass to calculateActivityCompletion% call, and the second element will be percentage amount that we are expecting to get after each call of calculateActivityCompletion% function. In other words, I'm simply moving values from the previous expectations into this array. This way, the same amount of expectations will be checked, but now we're splitting the data from the test implementation. And just to make it more clear what is going on in here, I'm gonna use calculateActivityCompletion% call in the description of this test, and inside this description we can use special characters to format some values. For example, since calculateActivityCompletion% function accepts numeric value, I can use %i to format numeric value, and it also returns numeric value, so I'm gonna use the same character as a return value like this. So these characters will be replaced by parameters that we are passing into test function. And please note that each time that this function is gonna be called, it will be called with different set of arguments that we have specified inside of the array of the each method. And there are a lot of different formatting characters that we can use in the description of such tests. If we'll search for the each word inside the Vitest docs, we'll get such page with explanation of each special character that can be used for formatting. So after doing all this, we can remove the previous implementation of this test and take a look at the test results. So these 3 calls correspond to the last test that we have just refactored. We're clearly seeing what data we were passing to each calculateActivityCompletion% call and what return value we were expecting. And in the case of any regression, for example, if we'll change value of one element of the first array, it is going to cause the first test for this group to fail. This way in test results we're clearly seeing which call exactly has failed. And as we can see, this kind of refactoring we can apply to those tests that have a lot of similar expectations, where only input data changes to the function that we are testing. Link to the source code of this lesson will be in the video description. Let's use the same technique we have used in the previous lesson to refactor tests inside functions.test.ts. Here we have a lot of tests with pretty similar expectations, so I'm gonna use method each on the test object that has to be imported from the Vitest library, and then I'm gonna move all necessary data that will be different for every test call into this array, extract parameter that we are passing into formatSecondsWithSign function. It will be the first element of these arrays. And the second element will be expecting return value. After we're gonna call function formatSecondsWithSign with respective argument. Then by using familiar technique we can change the description of this test. I'm gonna mention that this test checks formatSecondsWithSign function when we're gonna pass positive amount of seconds into this function. Since amount of seconds is a numeric value, I'm gonna use %i to format this value. And as a return value we're about to get formatted string, we could have used %s to format string, but in here I've used %o, that stands for object, because by using this formatting symbol, the string will be shown in the single quotes in test results. Then let's accept two parameters into the test function. And now I'll simply replace all hard-coded values in here. So every time this test gets executed, it will get different values for parameters, and therefore test results will be different. Let's switch over to the terminal and take a look at the test results. As we can see, our function has been executed 6 times with different values for parameters of formatSecondsWithSign function, as well as different expected return values of this function. Next, we're going to apply identical refactoring to the next function. In here, I'm also going to use methodEach, and then I'm gonna extract all necessary data from these expectations. Here I also need parameter for the function formatSecondsWithSign and return value of these functions. I'm gonna put all these values into arrays with 2 elements, and then let's just change the description of this test to follow same pattern. Here I'm gonna mention that we are testing the function formatSecondsWithSign when we will pass negative amount of seconds. I'm using %i to format numeric amount of seconds and %o to format expected formatted string. After doing all this, we no longer need all other assertions. We can leave only one assertion, but in this case we're going to supply different values every time this test gets executed, like so. And here we go. In total there are 12 calls of formatSecondsWithSign function. First 6 calls were checking that this function returns proper formatted string when we're passing positive amount of seconds, and last 6 calls were checking the same function but when we were passing negative amount of seconds. Now let's quickly do the same type of refactoring to the next test. It will be pretty similar to previous two. Here I'm also going to use methodEach and gather all necessary data for this test into this array by extracting parameter of the formatSeconds function as well as expected return value, like so. For the description, let's mention the name of the function under the test, formatSeconds, which accepts numeric value, and we expect formatted string in the end. And then every element from the previous arrays will be passed into this test function. First element will be passed into the first parameter, and the second element of those arrays will be passed as the second argument into this function. Moving on to the next test. As we can see, it has less expectations, but nevertheless those are pretty similar, which means we can also use same technique by calling methodEach and gathering all the data needed for these tests into this array. In the first case, if we're going to pass the string that cannot be converted to the number into normalizeSelectValue function, as a result, we're going to receive same string that we have passed. So 2 elements of the first array will be the same. The second scenario is when we are passing null value into this function, and as a result we're going to get null. And finally, if we're going to pass number as a string, at the end we're gonna get the same number, but as the actual number, not a string. So now let's remove all extra expectations and leave only one line. As a description, I'm gonna mention that we are testing normalizeSelectValue function, which receives one argument. Then we're basically accepting values from those arrays as parameters into this function and passing them further into normalizeSelectValue call, as well as into toBe method call, like this. And finally, let's do same steps one more time for the next test, which tests getProgressColorClass function. We have already done this so many times, so I'm going to quickly go through this procedure once again and extract all necessary data from these expectations by placing them into the initial array that is going to be used to run expectations several times. And then after extracting this data, I'll change the description saying that we are testing getProgressColorClass function which accepts one argument, which is a numeric value, and then all the data we are receiving as parameters into this test function, and then passing them further into respective calls. First parameter is going to be passed into getProgressColorClass function, and the second one will be used as a parameter for toBe method call. And after doing all this refactoring, we haven't actually changed any logic in our tests, but instead the main idea was to split the data from the test implementation. So instead we're using the same expectation, but every time our test function gets executed, our expectation receives different values. So we're still running our expectations with different values, even though we have only one expectation in a test function. So as for the last test in this file, it doesn't make sense to apply same refactoring because in here we have only one expectation. Let's take a look at the test results. As we can see, all expectations are passing. And now I'm gonna run all tests in the project. They're all passing as well. Link to the source code will be in the video description. Let's continue doing the same refactoring and turn some tests from other files into data-driven tests. Let's start with rotor.test.ts. In the first testing scenario from this file, we are seeing that the loop is used, and this is another sign that this test can be turned into data-driven test. And by data-driven or parameterized test, I mean the test which uses method called each with all the data necessary to run this test. So I'm simply going to call method each and pass this expression, which is going to return an array with page names. In that array, we're going to have 3 strings. Every time I'm going to output current string in this place, as well as take this string as a first parameter into the testing function. And then we no longer need to use loop in here, so we can simply remove this loop, and the rest of code can remain the same. In the terminal, we're going to see that that test has been executed 3 times, every time with a different value of the page name variable. Moving on, and if we'll take a look at the next test, this test can remain the same since it doesn't make sense to turn this test into data-driven, so we can move on to the next testing file, time.test.ts. This file contains lots of examples where we can use parameterized tests. Let's start from the very beginning. In here I'm gonna call method each. Let's not forget to import test object from the Vitest library. And since we're gonna need 3 different date objects to run the first test, I'm gonna extract all these date objects and put them as the first element of these arrays. This is the initial date we're going to use in order to execute the test. And as the second element of these arrays will be the date that we're expecting to get after executing the function after the test. By the way, in this case, these 2 dates are the same, and technically we could have used only one date object, but I'm gonna keep both to make it clear that the first date is used as an initial date, and the second one is used as an expected date. And as we usually do in such cases, let's change the description where we'll mention which function is executed during this test. Here I'm also gonna use a couple of special characters to format the data from those arrays and accept a couple of arguments. So the first date object we're about to receive is the initial date, and the second one is an expected date. Then we no longer need to define these 3 dates in here, since it is going to be passed as arguments into this testing function. And then I will remove duplicate instructions and keep only 3 lines in this test. But of course we have to pass these parameters into respective calls instead of using hard-coded values. So now that we are done with refactoring the first test, let's move on to the next one. In here I also start with calling method each, and then I'm going to take these dates one by one and put them into these arrays, so that later we're gonna be able to drastically reduce amount of lines in the testing function. Once the whole data is prepared, I'll change the description of this test and mention the function that we are testing. It's called tomorrow. Then I'll also use a couple of special symbols to interpolate date objects, and then I'll receive these date objects as parameters into this testing function. And then we don't need to define these dates in the test. Let's remove all these variable initializations and remove similar lines from the testing function. There will be exact same steps that we are going to do with the next test. As always, first of all, I'll call method each, and then I'll grab the data that we need to run this test and put it inside these arrays. The first element will be the initial date, and the second one will be an expected date that the first date has to be turned into after test execution. And as you may notice, these parameterized tests usually lead to removing the first phase of the test, where we are preparing the data, because data preparation has been moved outside of the testing function, and we are doing it separately by calling method each and passing all necessary data as array. So let's get rid of all these variable initializations and keep only one expectation. Then I'll rename description of this test and mention which function we're calling inside the test. And then I'm gonna forward all data that we are receiving as parameters into the testing function into corresponding function calls, end of hour, as well as toEqual. For the next test, I'm not gonna use data-driven approach, but here we also have some duplication. Let's just remove these extra expectations, since I think having only 2 expectations in this test will be enough. And finally, let's do the same refactoring for the last test. I'm going to quickly go through all that procedure once again. Firstly, let's extract all necessary values from these expectations, group them together into these arrays. As always, the first element of the array is an initial data we're passing to the function that we are testing, and the second element of these arrays is an expected value, return value of that function. This test is checking function toSeconds. Let's accept a couple of parameters, and then let's forward both of these parameters into function calls inside this testing function, like this. So we have done quite a lot of changes in this file, but those changes were pretty similar. So before finishing this lesson, let's just take a look in the terminal to make sure our tests are still passing. And also I'm gonna check all tests in the project. They are also passing. Link to the source code will be in the video description. When we are writing data-driven tests, besides using arrays as a notation to pass data into tests, we could also use object notation, and in this lesson let's consider a couple of other notations, how we can define parameterized tests. So I'm going to duplicate this test, and the idea is to basically rewrite these arrays as objects, where each key will correspond to parameter name we're going to pass to testing function. In this particular case, since we are passing 2 different pieces of data, they are called tracked seconds and percentage. I'm gonna have to define objects with a couple of properties to correspond to those names and assign appropriate values. But the main idea is the same. we're still going to execute testing function as many times as many objects are present in this array. And then to reference these values in the test description, instead of using %sign, we have to use $sign and the property name. So in here I'm referencing property with the name TrackedSeconds, and right here let's use %. And the way how we are accepting parameters in the testing function is also different. Instead of accepting separate parameters, we have to destructure those objects from the array we have passed into each method and reference individual properties. And then those properties can be passed further. And as you can see, after using object notation, all tests are still passing. But there is actually one more way how we can define parameterized tests. And this time we're going to use template strings to supply values to testing function. And it works like this. We are calling method each, and then using so-called tagged templates by specifying backticks. And the first line of this string is supposed to contain column names of our data. We have only two columns with names TrackedSeconds and %. And please note that all these columns are separated by vertical line. And then in order to populate this tagged template with values, we're going to interpolate values as usual. I'm going to quickly fill in this table with all the values we need for this test. And at the end, if we'll apply formatting to this file, as we can see, this table has been formatted as well. And the way we are referencing the data inside test description also stays the same, as well as the way how we are accepting parameters into the function. Here we can also apply the structuring to extract individual pieces of data. And there we go, all our tests are still green. But please note, if we're going to change this separator, for example, instead of vertical line, we'll use a different character. In this case, tests are going to fail. So these were a couple of additional notations we can use when defining data-driven tests. We can use whether array notation, object notation, or tagged template notation. I'm gonna keep only the first one, where we have defined parameterized test by using array notation. Link to the source code, as always, will be in the video description. Let's consider another interesting technique we can use when writing tests. There is one test inside timelineItems.test.ts file where we can apply this technique. As you can see, inside of this test we have a pretty lengthy definition of the object that we are using inside this expectation. So in order to avoid writing this definition manually, we can use so-called snapshot tests for this. And to use snapshot tests, we just need to call method toMatchSnapshot on this expectation object, like so. And what this will do is, when we will run this test for the first time, Vitest is going to generate object definition based on the supplied parameter into expect function, and use this definition as an expected value for this expectation. And since I already have Vitest running, if we take a look at the project structure, in here we can see a new folder, Snapshots, that was automatically created by Vitest when we called toMatchSnapshot method. And there is one file with an extension .snap, where Vitest has put definition of our expected value. As you can see in here, since we are expecting array of timeline item objects, Vitest has generated this array and saved in this snapshot file. So that next time Vitest is going to run this test, it is going to compare the value we have passed into expect function with the previously generated snapshot, thanks to toMatchSnapshot method. And this helps us to drastically reduce the size of this test, because now we no longer have to define definition of expected value manually. We can remove all this code. And now let's try to run only this test by using only modifier. As you can see, it's working. But the moment we'll try to change initial data for this test, let's try to change value of the our property of the initial array of timeline item objects. we're going to get a mismatch between initial data and then expected data that has been saved into the snapshot file, because that snapshot has been taken based on the previous data. But now the data has changed, and the previously generated snapshot is no longer valid. So to make this test pass again, we have to open up the snapshot and manually change updateTValue. And now it is passing again, but as you can see, doing all this manually every time we need to update snapshot is by far not the best way. So the Vitest can update snapshots for us. Let's change initial data one more time, switch over to the terminal, and as we can see in here, there is an option to update all outdated snapshots. We just have to press U. So let's do that and take a look at the definition of the snapshot. As you can see in here, value for the property hour was updated. So this is one way how we can use snapshots in our tests. But sometimes those snapshots are not that big, and it even makes sense to put snapshots directly in the testing function instead of creating separate files. And in order to make Vitest save snapshots directly in the testing functions, we need to use toMatchInlineSnapshot method. After saving the file, and if Vitest is running on the background, we can see that Vitest has automatically generated that same snapshot, but now instead of saving it in a separate file, it has put it directly in this one, inside this expectation. So we no longer need to keep that snapshot folder anymore. We can simply remove it, since we are storing snapshot directly in the file. And of course, same principles apply in here. If we'll change initial data, this inline snapshot will be no longer valid, so we'll have to regenerate it by pressing U in the terminal, and tests are passing again. I'm gonna do it one more time, revert the change to the initial data, and regenerate snapshots again. And the tests are passing. To make sure that we haven't broken anything else in the project, I'm gonna run all tests. They're all green, so we can move on to the next topic. Let's also not forget and remove that modifier only. Link to the source code will be in the video description. So far we have been checking test results directly in the terminal, and it is pretty convenient. Vitest even provides us with such an interactive menu, where we can choose several options, for example run all tests by pressing A, update snapshots by pressing U, filter tests by file name by pressing P, and some more. But there is also another way how we can check test results that Vitest provides us with, and for that we'll have to install separate npm package, which provides us with such UI, and we can check test results directly in the browser. It is called Vitest UI, so we have to install this npm package. Let's switch over to the terminal and run this command. And then to run Vitest UI so we can check test results in the browser, we just have to execute this command in the terminal. But for convenience, I'm going to add another script inside package JSON. For example, let's call it test:/UI, which will allow us to run Vitest UI by running npm run test:/UI command in the terminal. So let's do just that. I'm gonna switch over to the terminal once again and run this command. And right away a new browser tab is opened, and we can see Vitest UI. On the main screen we can see summary of our tests, how many tests we have, how many of them have passed, and how many have failed. Then we also can see a list of files with tests, and by clicking on each file, we can see all testing scenarios inside that file. We can also see what JavaScript modules individual testing files depend on. Then there is also a tab where we can see source code of testing files. Let's try to filter tests by name, and then we can run only filtered tests by pressing this icon. And we can additionally filter testing scenarios inside the filtered test file, and Vitest UI filters testing scenarios by using descriptions. To go back to the main screen with the summary, we can press this icon, and there is also an option to toggle between light and dark themes. Also, to open up particular test file in the editor, we can click this icon. Let's also see how Vitest UI shows errors. I'm going to intentionally make one test fail. And this is how Vitest UI shows us test failures. Here we are clearly seeing which testing scenarios have thrown an error. Alright, now let's revert that change to make all tests pass again. And besides this graphical user interface, test execution can also be controlled from within the terminal, just like before. Let's continue in the next lesson. So far we have been checking results of our tests directly in the terminal. And Vitest provides pretty good interactive CLI to control test execution. For example, here we can run all tests in the project by pressing A, or we can update snapshots by pressing U, or filter tests by file name by pressing P, and do a couple of other actions. And all the summary of test execution is shown directly in the terminal. But there are some other formats we can use in order to represent summary of test execution. This concept is called reporters. So in here, we can specify different reporters by adding test object and using key reporters with an array of reporter names. So this config has to be added inside Vit configuration file. So let's do this and take a look at the results. I'm gonna add test object with the key reporters. And for now, let's choose only one reporter with a name verbose and see how it affected test summary in the terminal. Right away we're seeing that Vitest has restarted since we have modified configuration. And if before this summary was showing only file names with tests without showing individual scenarios, but now that we have used reporter with the name verbose, besides showing file names, we're also seeing all testing scenarios within every testing file. Those are our test descriptions that we have specified for each test. There are a couple of other formats which we can use to represent these stats. For example, we can also print these stats in the JSON format. And besides showing all the stats in the terminal, we can also output these results in a separate file. And to do so, we have to specify another key inside configuration file. So if we're going to specify only one reporter, which is JSON in the terminal, we will see such output. This is a JSON object. Of course, it is not readable like this. So we can, so to say, redirect this output into a separate file. Let's use another key where we can specify a file name where the output should be redirected. I'm gonna save all the output in the file with the name test-report.json. And just because I currently have Vitest running in the project structure, we can see that this file has been created and the JSON report was generated. Let's open up this file and apply auto formatting. As we can see in here, we have a JSON object with all the summary of test executions. So here we can see how many tests were executed, how many of them were failed, how many passed, and so on. And by the way, having only one JSON reporter in the reporters array, when we're gonna run tests in the terminal by running npm test, we're not going to see summary in the terminal anymore. So what we'll instead see is this line, which tells us that the whole output was redirected to a separate file. But if we still want to see stats in the terminal, besides outputting it in the file, we need to add additional reporter, like this. And now we're going to see summary in the terminal, as well as in a separate file. Let's consider a couple of other formats which we can use to output summary of our test execution. Another option is JUnit, and this will generate test summary in the form of XML. So if we redirect the output of this option into a separate file, here we can specify additional files based on the reporter names, so that Vitest, besides creating JSON file, will also create .xml file. Let's take a look inside this file and see what output Vitest has generated there. And indeed, here we are seeing an XML syntax. Another option would be to use HTML reporter, and what this will do is it will generate separate folder in our project root. By default, this folder is called HTML. As we can see, this folder was generated since I currently have Vitest running. Then we can serve this generated HTML folder by using the following command and see results of test execution directly in the browser. So I'm gonna switch over to the terminal and run this command to open up generated report in the browser. But in order for this reporter type to work, we need to have Vitest UI installed, which we have already installed in one of the previous lessons. And here it is. This is pretty much the same Vitest UI that we have already seen before, with all the summary of our last test execution. So now I'd like to show one more reporter, which is pretty interesting, and this will be the most compact reporter. It is called dot. So let's use only this reporter and see how the stats will look like in the terminal now. So for every past test, Vitest shows such green dots. And if we're gonna intentionally make an error in one of our tests, we're going to see red cross instead of dots. And now let's revert that change and run all the tests once again to make sure we haven't broken anything. All tests are successfully passing. So in this lesson we have reviewed a couple of additional reporters, how we can represent stats of test execution. Feel free to choose preferred way, whichever feels best to you. And before finishing the lesson, I'm gonna go ahead and remove all automatically generated files, including HTML folder with a generated report. Link to the source code will be in the video description. When it comes to testing, there is an important term called test coverage. In other words, how much of our code is being executed during test execution. Because usually our code contains all kinds of conditional statements, and sometimes our tests might not go through all possible paths depending on the results of conditional statements. So it is very important to cover our source code by tests as much as possible. So that means that we need to write our tests in such a way that it will execute all possible ways that our code can run through. And when it comes to coverage, Vitest provides us with a couple of libraries that we can additionally install to enable this test coverage feature. So we're going to use the first option and install library called coverage v8. I'm gonna copy over this command and run it in the terminal. Let's wait until the installation process completes. And then in order to run tests with the coverage enabled, we just have to execute the following command. And to be able to run this command via npm, I'm going to add the following npm script in my package.json file. So let's open up this file. In here I'm going to add one more key. Let's call this script test:coverage. So now we will be able to run our test with coverage by running npm run test:coverage command. Currently in our configuration there are a couple of additional reporters used, and every time we're going to execute our tests, newly generated files with a report will be created. So I'm gonna remove all these additional reporters to avoid creating new files. And then let's try to run tests with coverage by running npm run test:coverage. And now, besides showing stats of test execution, we also see such table which shows how much our source code has been covered by tests. For example, in here we can see that all functions from the functions.ts module have been tested. And not only that, but we also went through all possible ways these functions can be executed, covering all conditional blocks as well. These numbers represent how many statements have been executed during test execution in percentage, how many conditional branches, amount of functions, and amount of lines of our source code in percentage. And just because our project is Vue.js application, we haven't touched Vue.js related parts, and which is why test coverage shows that some files haven't been covered fully. But this is fine because in this course we're only focusing on JavaScript unit testing, which means we do not test any Vue related code. Another way to enable coverage is via configuration file. In here we'll add another object under the key coverage and an option enabled with a value of true, like so. And now we can simply run tests by using npm test, and the coverage will be enabled automatically, and the table with the coverage is still being generated. There is also another convenient way how we can review coverage report, and that is by using Vitest UI. So to be able to see coverage result directly in the browser, we have to add reporter with the name of HTML in here. And if after this we'll try to run tests by using Vitest UI, the new browser tab will be opened with Vitest UI, and here we see an additional icon, by clicking which we're seeing coverage report. Here we can click around and open up different files with source code to see which lines were executed and which lines were not during test execution. For example, if we're seeing the green color next to every line, that means these lines have been executed during test execution. But if we'll take a look in another file, here we're also seeing red color, which means that those lines and functions were not tested yet. As you can see, it is much more convenient to view generated coverage report directly in the browser. And if we would want to still show coverage table in the terminal, we'll have to use text option. And after running npm test in the terminal, we're seeing coverage report. And this is what test coverage means, a very important concept when it comes to automated testing. Link to the source code will be in the video description. In this final lesson of this series, we're going to do some minor improvements to some existing tests. First of all, I'm gonna go into vit.config.ts and remove configuration, which enabled coverage feature. In this lesson, we're not gonna need to generate coverage report. Also, another thing, if we'll switch over to package.json, in here we have a script defined to run all tests in the project called test, which enables us to run npm test in all tests in the project will be executed. But the Vitest execute tests in watch mode, so that means Vitest will keep running and watch for changes, and anytime we're going to change some files, it is going to execute tests again. But sometimes we don't need this, we just wanna run tests once, and for that I'm going to add another script called test::run, and in here we just have to additionally supply command called run, like so. And if I'll try to run this command in the terminal, we can see that Vitest has run all tests, and at the end, the command has quit, so Vitest doesn't watch for changes. Next, let's open up file functions.test.ts, which contains one test where we have used mocks. In here we were using mocks to mock return values of two functions, function now which returns current date, and function random which returns random value. And to improve this test, we can also check how many times certain mocks have been called. For example, I'm going to store these mocks in constants. Let's call first one nowSpy to know which function this mock is mocking, and the second constant we'll call randomSpy. This mock is used to mock function random. And then we can write the following expectation. I'm gonna use expect and pass first mock, and then if we'll call to have been called method, this way we're checking if this mock has been called at least once. So now if we'll run only this one test by using modifier only, and indeed test is passed because our mock is called inside id function. But if we'll try to change function implementation by removing the call to method now, in this case, in a terminal we're going to see that test starts throwing an error, because we were expecting method now to be called at least once, which hasn't happened in this case. In addition to checking that mock is called at least once, we can also check if mock is called a certain number of times. And to do this, we have to use another method called to have been called times. And as an argument, we have to supply how many times we expect this mock to be called. In this case, I expected this mock to be called 2 times, but in fact, it has been called only once, hence we're seeing this error. And then I'm going to duplicate this expectation and do the same with another mock. We are expecting this mock to be called only once. And then let's remove this modifier only and run all tests. And they are all passing. The next thing that I would like to improve has nothing to do with tests. It is related to import statements, because in some files we are importing types without specifying keyword type. But whenever I import types, I actually prefer to include keyword type to make it clear that we are importing types. So I'm gonna add this keyword in here where we are importing activity type, as well as inside of another file. Here we are importing 2 types. Let's add this keyword in here as well. Next one. Before we have used modifier skip and only to specify which tests have to be skipped and which ones have to be executed. But in addition to those modifiers, we can also use modifiers skip if and run if, which allows us to add additional condition under which certain tests have to be skipped or run. For example, if we're using skip if, we can pass boolean value which indicates when this test has to be skipped. So if we will pass truthy value, this one will be skipped. And another similar modifier is called run if. This does the opposite. If we're gonna pass falsy value, this test will be skipped, otherwise it will be run. And let's also consider another modifier called fails. For example, if for some reason we expect some tests to fail, and if this failure is expected, for example, let's change this value to make this test fail, and it is currently failing. So if this change is intentional and we are expecting this test to fail, we can specify modifier fails to make test runner to not throw an error, because we are expecting this failure. But in case the test where we are expecting the failure will not throw an error, test runner will show an error in the terminal. Another thing is that we can specify custom error messages for certain expectations. For example, if we are not satisfied with the default error message, we can additionally specify custom message that will be displayed right next to the default one. And to do so, we have to pass second argument into the expect function. So right here I'm going to specify custom description. That will be the reason which caused this expectation to fail. And in the terminal we are seeing our new description right next to the default one. So this is how we can specify additional error messages to any expectation by passing them as the second argument into expect function call. The next thing is related to parameterized tests. Whenever we were using parameterized tests, we were calling method each on the test object. So each time we had to import that test object. But in fact, method each can also be called on the it object. And just because we are already importing it object into every test file, there is no need to import additional test object. So I'm gonna go through all the places where we're using test object and replace those with it objects. This way we're not changing any logic. And also let's not forget and remove imports of the test object, because we are no longer using it. And finally, there are a couple of test descriptions which can be improved. For example, for the test which checks function today, we're seeing that this function today does not accept any arguments, but in fact, our description says that it does accept one argument. So I prefer to change this description by simply saying that this test is checking that function today returns current date. And due to the same reason, I prefer to change the description of the second test, which tests function tomorrow. As we can see, function tomorrow does not accept any arguments. So let's rename this description and say that this test checks that function tomorrow returns date of tomorrow. And lastly, if we'll open up file activities.test.ts, here in the last test we're checking the function calculateActivityCompletion percentage, which accepts 2 arguments, but in the description, we are specifying that it accepts only 1. So I'll improve this description and literally specify activity word as the first parameter to match number of arguments that this function accepts. And those are all improvements that I was planning to do in this lesson. Since this was the last lesson of this series, let's run all tests in the project one last time. Make sure that they're all passing, and let's finish this series. Link to the source code of every lesson will be in the video description.